In this video, I may be highly wrong, but I'll just attempt to do this. Alright, so in the previous video, we actually do trying to transform your this piece of information into a bar, x bar, b bar over here. As you can see, we transform things. Right, now in this video, we're gonna explain to you how these transformations can be useful to our system right now. Alright, because still we're gonna input into our controller, but we can have a controller that can be a controllable controller, or we can have a reachable controller. Alright, these two things. Alright, so therefore let's explain to you what is actually the meaning of a controllable and a reachable system. Alright, and therefore I will boldly try to expand this thing as this thing over here, and I may be wrong lah, okay, but that's how I feel it is. Alright, is that your ax, alright, is your ax over here, okay, your a times x plus, alright, bu, okay, plus bu will give you a new x dot over here. Okay, so therefore we using this understanding, we somewhat can do something. Alright, the controllable system states that if you have a certain state that is x naught, alright, when you somewhat bring it from some time 0 to certain finite time, it can be a short time, can be a long time, depends on whatever you want. Alright, eventually you'll let it be 0. You'll let this state x naught to be 0. So graphically, if I were to zoom in, alright, graphically, if you have a certain x naught over here, okay, if you input a certain u, alright, a certain input u, interacting with this x naught over here, okay, eventually, slowly, you'll somewhat change it all the way to 0, okay, and at time t, so xt is equals to 0. Alright, this is kind of fine for a one variable system. If you still remember, what we are dealing with is something that is multi-variable. This thing over here can be a multi-input, multi-output. Alright, so my input is actually my u. So I was thinking, so we were thinking that can we have a single input but a multi-output system? Okay, so a single u can actually converge or steer all your x naught, alright, all different states to 0. So what does I mean? What do I mean by this? If I have, for example, a multi-variable state, alright, x naught, x1, and x2, all over here, alright, we can say that the system is controllable if and only if the x2 will eventually goes to 0, x1 eventually goes to 0, and x0 eventually goes to 0. Each of them have their own xt equals to 0. They have their own x. Maybe I should label as xt2, t1, and then over here is xt0 is equals to 0. As you can see, if I have a certain input, alright, a certain special input such that we can control all the state into 0, then we can say that this particular input, alright, is a certain controllable system. Okay, I shouldn't say that this input is a controllable system. I should say that this states over here is controllable. Okay, this is the state of your system. Alright, whatever feedback that you take back in. Okay, so therefore, if you happen that you have certain good input such that it inputs already, it changes some informations and it output. Alright, eventually at some point of time xt is equals to 0. Okay, and then you feedback to the controller and it goes something else. I don't know what the hell is gonna be happening, right? That's why I say that this video will be a very vague one and maybe highly chances that it may be wrong. But as for this thing over here, I actually sourced it from this person. You can watch it out. Alright, you can type in this thing, it should be fine for you. Okay, it's kind of helpful. I kind of know a little bit about that stuff, but I may still be wrong. But anyway, so this is something like a controllable system, alright, where you steer your state to the origin 0. A state x0 is said to be controllable if from certain finite 0 to t, or as we have said earlier, from time 0 to whatever time that you may want, alright, where in the end xt is equals to 0. Alright, then if all states, Alright, that's what I've shown you. If all these states are all 0, which is over here right now, then this means that your state variables, your axis, x1, x0, x1, x2 are all controllable. Okay, so far so good. Now likewise for reachability. Reachability on the other hand is that state, if given at time 0, alright, if I have like x1 and x2 for example, they are at time 0, alright, it's said to be reachable, alright, if and only if that this x1 move to this x1 over here, and then this x2 move to this x2 over here, then it's considered completely reachable, because you have your x1 and x2 reach wherever its particular x1 bar and x2 bar point. Okay, I hope that this is pretty clear for you. And at this point of time, when it reaches this point, or at this point of time it reaches this point, this one will be xt, alright, this one will be xt, but in a different time, this is maybe is time 1, time 2. Okay, so therefore by the definition, the state x0 is not 0, alright, which is at this point over here, which is non-zero, is said to be reachable if the given x0, or which is x1, x2 at time 0, alright, is equals to 0, which is at this point lah. Okay, there exists a finite time interval from 0 to t, which is from 0 to whatever time that you eventually reach this point, alright, is that when x reaches time t, alright, this means that you have already reached x1 bar, alright, your desired reachable state. Alright, so if all of these states that are reachable, meaning x1, x2 reaches whatever state that they want, alright, then we can say that it's a completely reachable system. Alright, and all these are in the time domain. So far we have been talking is all the time domain, because from t equals to 0 to time whatever t that you want. Alright, but it's not what I want, but in terms of how the variables would change. Alright, eventually it reaches 0 or reaches your x1 or x2 bar. It depends on what time. Alright, and also depends on what input you're going to input. So your higher the input, you're going to steer it more faster, but you're going to have a more unstable system and things like that, but we will not go into that because I also don't know what the hell is going to be going on. But at least you get a feel of how the explanations comes into visually play or whatever it is. So at least it helps you to better memorize your stuff. And as I say, this is for the time system, for either a controllable system or reachable system. Alright, then now you're gonna ownself go and memorize, alright, for this thing. This is for the digital system. Alright, if you have certain xk plus 1 is equals to 0, then your system is completely controllable because it's equals to 0. But why it must be equals to 0? That's the thing, I don't know why. But just memorize, because I find for the whole day I can't find any answers to it, which is very anyway, so therefore if this is equals to 0, definitely you didn't reach any non-zero system. Alright, this is definitely 0, but you didn't reach any non-zero, meaning like 5, 4 or whatever. So therefore you can clearly see that the state is not reachable. Alright, it's not reachable at all. Alright, and therefore to some understanding, alright, I don't know what understanding is this. Alright, I don't know what the hell this comes from and where the hell this thing gonna influence our decision making. But in the end, it says that in discrete time, which is in digital time, alright, the controllability is somewhat more important in comparing with the so-called the reachability system. Alright, I don't know what it means, you just accept it. Alright, that's life now. So that I hope this is pretty clear for you to understand the definitions behind your controllable and reachable. At least you get a feel of we are dealing in terms of a multi-state variables. There's multi-states. Alright, where x is your state. Okay, so I'll leave you to this. In the next video, we'll discuss briefly also about observability and reconstructability. Alright, and then later on in the third video, we'll see how it goes. Alright, so see you there then.